I'm Anil Kumar, and here is a very interesting question for which I'm providing you with a very general solution. The question here is, find the dimensions of right circular cone of minimum volume which can be circumscribed about a sphere of radius b. So here's a figure for you. So this is a cross section of a cone within which we have a sphere, right? So the sphere here is of radius b. So let us say this is radius b for the sphere. That means from the center of the sphere to the edge, it will be b. Cone is circumscribing the sphere. So let the height of the cone be h. So this is what we need to find. Height and the radius. So radius be r. Let us say this is the radius for the cone. This is what we need to find, radius and height. So what you can say is that height could be combination of the radius of the sphere plus that much. Let me call this as y. Okay. So this is y for us. Now what we will do is we will try to relate radius with this parameter y. You can notice that we have two similar triangles. Let me show you two similar triangles here. Let's say this point is A, this is B for us, and this is C. So big triangle ABC and the small triangle AO, let's call this point as P. They are similar since in these two triangles we have 90 degrees, one of the angles, right? So these are 90 degrees angles. So big triangle and small triangle, one of the angles are 90, and then we have one common angle, right? So A is common to both. So because of AA, right, so the property A, two angles, we can say that the triangle ABC is similar to triangle APO. I'm writing APO since B and P are 90 degrees. Now since they are similar, their corresponding sides will be having the same constant ratio. So side opposite to angle A for the big triangle is R, so we can say R divided by, in the small triangle it is B, should be equals to, this triangle AB is Y plus B, right? So Y plus B divided by this side opposite to, that is Y plus B is opposite to this side. In small triangle that will be the angle and AP is the side. So what is AP? Well, AP should be, because this is 90 degrees, hypotenuse y, so AP is square root of y square minus b square, right? So that is AP, right? So this is, so AP will be y square minus b square square root. That is a right triangle. So we can write this as square root of y square minus b square. Now from here you can relate r with y, right? So we can write this as r equals to b times y plus b divided by square root of y square minus b square. So that is the relation, which is very important. I hope this is absolutely clear to you. So we will kind of further explore the volume of the cone and then use this relation to find maximum or minimum volume, correct? So volume of the cone can be written as 1 by 3 pi r square times height h. Now from the diagram we can see that h is y plus b and r square, we already have what r is, we can square this, right? So a square of this will be, let me square it, right? So b square times y plus b whole square divided by square root square will be y square minus b square times height. Height is y plus b, right? So we can write this as y plus b. So that is what we get as an expression for volume. So we can simplify this since this is difference of squares. So let me continue here to simplify this a bit. 1 over 3 pi b square y plus b whole square times y plus b in the numerator. Denominator is y plus b times y minus b, right? So So from here, y plus b, one of these factors can be cancelled. So what we have, v as a function of y, which could be written as 1 over 3 pi b square y plus b whole square divided by y minus b. So that becomes the expression for volume of the cone. Now this, we can find derivative with respect to y. So we get 1 over 3 pi, b is constant, right? So b square will take constant. That is a part which is variable. So let's find the derivative of this one. We'll use the quotient rule. So we get y minus b whole square, derivative of numerator, which is 2 times y plus b times y minus b, minus derivative of denominator times the numerator, that is 1 time, we get y plus b whole square, right? Now, for maximum or minimum, we need to find the critical point, right? So the critical point is when this derivative is equal to 0. So that is how you can get the critical number, right? So that is the critical number. You can also see here that the value of y could be 0, or we'll use second derivative to find whether about this relation. Okay, so critical number is when the derivative is 0. Okay, so when will this be 0? Now these are all constants. It can be 0 when this term is 0. So let us write down this term and equate it to 0. So we have 2 times y plus b times y minus b minus y plus b whole square equals to 0. So you could expand and simplify, but better way is to factor out y plus b. So let me factor y plus b, and then we are left with 2 times y minus b, and here we have minus y plus b, right, equals to 0. Let's continue. Y plus b, so this term here is 2y minus 2b minus y minus b equals to 0. Then we get y plus b, and 2y minus y is y, minus 2b minus b is minus 3b equals to 0. Now this will be 0 if y equals to 3 times b. You get the idea. So y equals to 3 times b is what gives you the critical number, right? So that becomes the critical number for us. So now to analyze whether we get a maximum or a minimum here, we can actually write our derivative in terms of the simplified version, which is 1 over 3 pi b square, and here within the brackets we simplified the numerator as y plus b times y minus 3b, right, divided by y minus b whole square, right? That is how we simplified the numerator, correct? Now, to show that this is indeed the minimum volume, what we should do? We should check a value which is slightly less than this and slightly more than that, right? And see how does it vary. So let's take a point. This is our critical number, which is 3b, right? We're trying to analyze the rate of change of volume with y. Now, if y value is less than 3b, let us say that y is 2b, right? Or if it is more than 3b, let us say it is 4b. In that case, what happens to the derivative? Now, clearly, in this particular case, these two terms are positive, and this could be positive or negative depending on the value of y. So if y is 2b, we have negative value here, correct? So negative, this is negative, and if y is 4b, this term is positive. Now negative means that the derivative will be decreasing, so the function is decreasing. Do you see that? That is negative. And positive means the function is increasing. So clearly what we get here is a minimum. So from the first derivative test, we get a minimum at y equals to 3b, right? So in general, we will say that the radius, now we can find the radius using the formula here, y equals to 3b will substitute, and height will be equals to b plus 3b. So in general, we have a solution here that y equals to 3b means height is equals to 3b plus b, which is 4b, so 3b plus b, which is 4b, and the radius r is equals to, we'll write 3b here, so we get r equals to b times 3b plus b is 4b, right? So we get 4b in the numerator divided by 3b square for y will give me square root of 9b square minus b square. Do you get the idea? So that should be equal to, let me use a different ink, okay, different pen. So this value is, so we have 4b square in the numerator divided by square root of 8, and b square is common, we can take this out. So it becomes 4b over square root of 8 is 4 times 2, so it could write 2 square root 2, and that gives me 2b over square root 2 as the answer, or square root 2b, right? So which is r is equals to square root 2 times b, right? So square root 2 times b is the value of r. So we can write down now our answer, substituting these values, that the cone radius will be equals to square root 2b, and the height of the cone will be equals to 4 times b, where b is the radius of the sphere, right? So I hope these calculations are very clear. They are kind of intricate calculations, kind of difficult. So go through it once again, and then we'll take one example. We'll put some value for b so that it becomes easy to understand. I hope that helps. Thank you, and all the best.